So today we're going to study three types of variation. We'll start with the most basic, which is almost intuitive to us. It's called direct variation. And so with direct variation, you've basically got an x and y value. X as, like just generically, as x increases, the y value is also increasing. So a graph of that usually going to start with a point at the origin. And as one increases, the other increases, or this one decreases, the other one decreases. So it's a direct relationship there with the two. So here's an example of gallons of gas and miles driven. So it looks like the more miles you drive with this particular car, the more gas you use. Well, I think that's true with just about any car. What's interesting is the graph is a straight line. So this is a constant rate of change. Maybe this car is driving on an interstate, on a flat interstate. It just has on cruise control. And it looks like for about every 30 miles, they use 1 gallon of gas. So essentially, for every 30 miles they're using 1 gallon of gas, they're getting 30 miles per gallon when they're on this trip. And so that's typically, so in this case, this formula would be able to figure out that's your K value in the formula. That's the ratio that you're getting. 30 every time you go 30 miles, you use 1 gallon, kind of thing. So let's look at another example. That's just a real world example for a minute. So this formula, C equals pi d. Now notice pi is not actually a variable. So again, it's like a common ratio. So if you take the diameter of any circle, so you have a circle, diameter is 10, multiply by pi, you actually have the distance. It's kind of interesting, the distance of the circumference. So that would be 10 pi, right? It's just C equals pi d. So you multiply that diameter by 10, by pi, you always have the circumference. So that's a common kind of, so a lot of formulas are set up this way. It doesn't mean, in either case, like in this case, it doesn't mean that every extra mile you drive uses a gallon of gas. It's some kind of ratio. As the mile goes up by 1, by 30, the gallons of gas go up by 1. So it's kind of proportional kind of growth here. And that's what we're talking about. So this is the official formula. I know it looks like a variable. I want you to think of this K as, it's called the constant proportionality. Don't think of it as a variable. Think of it as a constant. Once we figure out what it is for this particular problem, we will just use that. We won't actually, we'll plug in values for X and Y, but we won't plug in values for K once we figure out what it is for that problem. So the formula says this: Y varies directly as X, and that's usually what the problem is. In this case, the formula would be Y equals KX. So Y is varying directly in some kind of proportional way with X. And so it might be 1 out of 30, that would be 30 miles per gallon. It can be any kind of proportion. So if they wrote this to us, P is directly proportional to U. P equals K times U. So that K represents, that's a U there, that K represents the constant of proportionality, some proportion that we're multiplying to get that. So this might be a problem, typical kind of problem, at least starting out here. It says Y, it starts with Y is directly proportional to X. So I'm going to write my equation. Y is K times X. So that's a directly proportional kind of problem. It says if X equals 3, then Y equals 15. So in this case, we're going to plug in X and Y. So Y is 15. K we don't know yet, and X is 3. We'll solve that for K. It takes one step. Divide by 3, you get K equals 5. Okay, I found K. Then write the equation, or sometimes it'll say write the function rule. So, remember K is not really a variable. K is going to be a number. So the function rule for this one will be Y equals 5 times X. And now if they ask a follow-up question, which a lot of questions will, what happens when X equals 10? Well, Y would equal 50, right? We know the proportion is just 5 times X equals Y. So this is your function rule or your equation. You've got to plug in and find that K value. That's not a variable. It's a constant of proportionality. So I'm going to solve this one 2 different ways. So a very similar kind of problem goes a step further than the last one. So first just start with the equation way. And I really like this way. So Y equals K times X. You got to remember that equation. X equals 12 when Y equals 3. So Y equals 3. x is 12, divide by 12, you get k equals 1/4. So my function rule is y equals 1/4 times x. Right, we just plugged in our k value. Now it asks a follow-up question. It says, what is the value of y if x is 30, right? So you're going to go, well, y equals 1/4 times 30. 30 divided by 4, 30 divided by 2 is 15, so 30 divided by 2 twice, which is divided by 4, is 7.5. And let's kind of look at this, big picture. So x is 12 when y is 3. X is now 30, so x got bigger, which means y has to get bigger at all as well. Because remember, this is a directly proportional. As x gets bigger, y gets bigger by a proportional amount. So that makes sense. Using proportions is another way of solving this. So if x equals 12 and y equals 3, x equals 12, y equals 3, that's x divided by y. So x is 30, y is we don't know. Multiply this guy, you get 12y equals 90. Divide by 12, divide by 12, and I'm pretty sure 7.5 times the 90 divided by 12. So that's 7, yeah, let's see. Let's make sure. So 90 divided by 12 is 15 halves, which as a decimal, control, enter, is 7.5. Just make sure. So we get the same answer both ways. This way, I'll just tell you this. The question often says, what's the constant proportionality? This doesn't really tell you that, right? Another way of thinking about this is, like some students will do this, it's kind of a neat way of handling it. If you solve for k, right, the x's cancel over here, you get k equals y over x. That ratio should always remain the same. So if we have like y over x, 3 over 12, is the same thing as y over x, 7.5 over 30. Right, those should be the same ratio, which it is 1/4 in both cases. So that'd be one way of doing it. So now we have inverse variation. This is the formula for inverse variation. Y varies inversely as x. So instead of k times x, it's k divided by x. The big concept here is as one value increases, let's say x increases, the y value will be decreasing. So instead of both increasing at the same time, one is increasing, one is decreasing here. So look at the graph here. This is a common, like a science class kind of formula. Pressure equals K divided by V. It's called Boyle's law. And as you see on the graph, as x is getting bigger here, the y value is getting smaller. As x gets smaller, the y value gets bigger. So these things are going in reverse order. Speed and time. This happens with speed and time as well. So, so as time gets more, speed, just think about it, like the time it takes you to get to school in the morning. If you drive with someone who drives really fast, as the speed is fast, the time goes down. If you drive with someone who drives really slow, the time it takes to get to school is a lot more. So those are inversely related. So as one goes up, the other one is going down. That's the idea of inverse variation. So let's actually just work a problem or two to make sure we understand this idea. This is kind of an easier type lesson. You've probably spotted that already. So first, like if x varies inversely as t, that would be x equals k divided by t. So that inverse variation is one gets bigger, the other one gets smaller. This one says y is inversely proportional to x, y equals k divided by x. If x equals 3, then y equals 15, so y is 15. K I don't know yet, but x is 3. Multiply both sides by 3. You get k equals 45. Write your function rule, which would be y equals 45 divided by x. Find k, it's 45. Write the equation, we wrote the equation, it's that, we got it. So here's just taking it to the next level. let's do this with first with the equation and then with proportions. So y equals k divided by x. It's inversely proportional. X equals 18 when y equals 6. So y is 6, x is 18. Multiply both sides by 18. 60 and 48 is 108. So 108 equals k. So my function rule would be y equals 108 divided by x. If they're inversely proportional, if x equals 12, that would be y equals 108 divided by 12. 8 times 10 is 120, so times 9. So I think that would be y equals 9. Let's see if that makes sense. X equals 18 when y is 6. X went down, which means y should go up. That makes sense. So that's definitely works. So you get proportions. This is where it gets tough. If you see this, don't put 18 over 6. It's not going to work. Don't put 18 there. You have to put them diagonally from each other. The other two go in either spot here. And then just cross multiply, solve. You got the same answer of y equals 9 when you do it that way. But I really like this because I'll ask about constant proportionality. I'll ask about the function rule or the equation of the graph. Last but not least, sometimes equations are a little bit more complicated. Some things may be varying directly, and some things may be varying jointly. So a good example would be area and base and height. 1/2 is like your constant proportionality, but area varies with the base in a direct manner, and area varies with height also in a direct manner, in a direct variation. So you've got more than one thing that things are interacting. There's a more complicated formula. In that case, 1/2 is your value of k. Okay, let's look at one last problem. Almost done. It says M is jointly proportional. When it says jointly, you can think of that as saying directly proportional to A and B and C. So M equals K times A times B times C. And inversely proportional to D. So I'm going to divide by D because, again, inverse is you're going in the opposite direction. One's increasing, one's decreasing. It says if A and D have the same value. So if A and D have the same value, I think we can actually cancel those, right? If A and D was 3 over 3, 4 over 4, we can cancel. And if B and C are both 2, okay, so let me rewrite this. This would be M equals K times 2 times 2. Those are both 2. What is the equation? So, and M is 128. So now we know 128 equals 4K. Divide by 4. Let's see if we can do that in our head. K equals 32, I think. Okay, so we found our value of K. What is K? What's the equation? Plug it into the function rule. So this would be M equals 32 times A times B times C all over D. Or they're kind of sloppy, but I think you can see it as an equal sign right there. Again, so 32 is not really a variable, it's a constant. Once you find it, immediately plug it back into the equation to find the function rule or find the equation there. That's your lesson.